This is part 2 of 5.4. The objective you already know. Let me move on to the next slide. Number 8 says write the trigonometric expression as an algebraic expression. Notice that you're computing cosine of the difference of two angles. This is your first angle, this is your second angle. Keep in mind that we're dealing with arc, sine, arc, tangent. So these are inverse trig ratios, which you know that represent angles. So that's why we're going to let u equal to the first arc sine of x and v equal to this arc tangent of 2x. From here, by using the definition of sine inverse, you know that we have this. This is sine over 1. I'm going to draw a right triangle using u as my reference angle, and this is what I get. This is the missing side, but I should be able to find this using the Pythagorean theorem. I do the same thing for this second equation, tangent inverse. By definition, we can write this, tangent of v equals 2x. This is 2x over 1, right triangle, this is what you get. This is your reference angle v. Now, this is what we're going to do next. In a little bit, we're going to be using these right triangles here. I didn't write the 90 degree, but you should be able to see that. Cosine of u minus v. Why? Because we said that this was equal to u and this is equal to v, and we have the difference. I apply the formula that you know for cosine of the difference of two angles. This is what I get. Now I'm going to be computing cosine of u. So I need to go to the reference angle here, this right triangle with reference angle u, and I compute cosine. And that's how I get this ratio. Then I compute cosine of v. So then I go to, I'm working with the reference angle v, so I go to this other right triangle and compute cosine of this right triangle. This is what I get, plus sine of u. This is my reference angle now. I compute sine, which is just x over 1, or just x, and then sine of v. So I go to the other right triangle, and this is what I get. And then at this point, all I need to do is just clean this up. And I notice that I have the same denominator, so I can add the numerators, and I can just leave it like this. And you don't have to rationalize this expression here. This is your final answer. Moving on to number 9. This is a lot easier than number 8. It says find the value of the expression without a calculator. It says cosine of, and then you have sine inverse of -1, cosine inverse of 0. Now if you remember, this represents an angle. And you should feel comfortable answering or seeing why this is the answer. This is saying for what angle do you get -1 for sine, and it's negative pi over 2. And you have done this before. For the second one, for what angle do you get 0 for cosine, and it's pi over 2. And keep in mind, since we're dealing with inverse functions, you have to follow the restrictions. And all this, at this point, all I'm going to do is I'm going to substitute, instead of writing sine inverse of -1, I'm going to write negative pi over 2, pi over 2 for cosine inverse of 0. And then I simplify this, which is just cosine of 0. Cosine of 0 is equal to 1. This is not inverse, it's just cosine of 0. If you refer to unit circle, you should see that it is equal to 1. 10, very similar to number 9. Again, give me the angle for cosine that gives you -1/2, which is 2 pi over 3. Same thing for this one, which is pi over 2. And then I go over here, and instead of writing the inverse trig functions, I'm going to write 2 pi over 3 and pi over 2. And I don't have to, let me going back to this one, I don't have to expand. I can just simplify this, and then I get this, and this is my answer. In the same manner, this is what you get. If you simplify this, just come up with the least common denominator, add these two fractions, and you get 7 pi over 6. Cosine of 7 pi over 6 is equal to negative radical 3 over 2. Let's go to the next slide. It says verify the identity. We're looking at making one side equal to the other side. I look at the right side and it looks a lot easier than the left side, so I'm going to work on the left side. All I'm going to do on the left side, I'm going to expand this using the formulas for sum of cosine and difference of cosine. And this is what I get for the sum, this is what I get for the difference. And all I need to do next is, I notice that I have negative sine x sine y, positive sine x sine y, so I know that this goes away. And I'm left with these two expressions, which are like terms. That's why I get 2 cosine x cosine y, which is what I wanted to equal. Number 12. This one's a little more tricky, but you should be able to follow along. So again, I'm trying to make one side equal to the other side. I'm going to work on the left side. This is more tricky, more complicated than this one. What I'm going to do here, I'm basically going to expand, I'm going to expand sine of x plus y, sine of x minus y, and this is what I get. This generates a binomial, this generates another binomial. I'm taking the product, so I'm going to take the product of these two binomials. When I do that, this is what I get. It's a long expression, but you should be able to follow that this is the answer once you FOIL this product. So now at this point, you notice that these two are like terms and they go away. And it looks a little bit nicer. I mean, it looks close to what I wanted to equal, but not there yet. Okay. So now what I'm going to do, I'm going to work with this one. Why? Because it works. If you work with this one, it's going to look like what you're trying to achieve. If you work with the other ones, you may get there or you may not. Okay. But if you work with this one, what do I mean if you work with this one? I'm going to rewrite this using the Pythagorean identity. So this is what I get. So notice this is the same. This is still the same, sine square x minus, and this is still the same. And the only thing that changes is I'm using the Pythagorean identity for cosine square y, and this is what I get. Now at this point, I'm going to distribute this, and this is what I get. Sine squared x minus sine squared x minus sine squared y. Once I distribute this monomial to this binomial, this is what I get. And then I'm bringing this down. And then at this point, you should see something. If you look at, ignore this for a second, notice that these two expressions, these two terms, they have a common factor of sine of y. Sine of y, sine of y. In addition to that, they have a negative, negative. So if I pull out this negative sine y out of these two last terms, this is what I get. Now, notice if you were to multiply this into this binomial, you end up with the previous step. At this point, you should be able to see something happens with this expression inside the parentheses by applying the Pythagorean identity. And this is what you want. This is your answer. And this is the end of 5.4, part 2.